For this question, given two complex numbers, z1 equals to 5 plus 3i and z2 equals to 2 minus i. For the first part, A, state the conjugate of z1. So for conjugate of z1, we're going to change the imaginary part from negative to positive, or from positive to negative. So for this positive 3i, conjugate will become negative 3i. Meanwhile, for conjugate complex number z2, it will be 2 plus I. Then for question B, determine the value of k if 1 over z1 equals to k times conjugate of z1. So for this question, we can simplify, where we can notice that we can take out the k, then the operation will be z1 times with conjugate z1. So we find out this 1 over k, then we inverse back. So for z1, it will be 5 plus 3i times with its conjugate 5 minus 3i. We simplify, where complex number times with its conjugate, the concept will be a square plus b square. So for this part, a square is 25, b square is 9. So 1 over k will equals to 34. Then we inverse, k will equals to 1 over 34. Then for part C, for the first part, 5 z1 times z2. So z1 is 5 plus 3i. z2 is 2 minus i. We expand this, where 5 times 2 is 10. Then 5 times negative 1, negative 5i. Then 3i times 2, positive 6i. Then minus 3i squared. So for I squared, we can simplify it to become negative 1. So negative 1 times negative 3 will become positive 3. Finally, we get real part is 13. For the imaginary part, negative 5i plus 6i, it will become positive I. Hence, means use this result, we're going to show this. So when you want to show this conjugate z1 times conjugate z2 equals to z1 times z2 conjugate, so we can notice that left hand side we have calculation, right hand side we have calculation. So in order to show, the working will be separate out. We need to take up what's your left hand side, where the operation will be conjugate z1 times conjugate z2, which is 5 minus 3i times 2 plus I. We expand this, it will be 10 plus 5i minus 6i, then minus 3i squared. So again, I squared is negative 1 times with negative 3, positive 3, it will give us 13. Then for imaginary part, it give us negative I. Then we separate our right hand side. We try to calculate this for conjugate z1 times z2. So z1 times z2 we already obtained before it. So we use that result. Therefore, we can see our questions here. It got hence. Hence means use the result before this to answer this part. So z1 times z2 obviously is 13 plus I. To conjugate it, it will be 13 minus I. Now we can notice that our calculation for left hand side is equals to right hand side. Therefore, we managed to show that conjugate z1 times conjugate z2 is equals to conjugate z1 and z2. Then we continue for the important part here. For the first part is our basic to knowing conjugate, complex number conjugate. Then for part B, you will be operating, finding your K, multiplying, and then inverse the value to find out our answer. K is 1 over 34. Then for part C, when we're doing show, firstly come up with this multiplication first. So multiply it correctly with the answer. Then for the showing part, left hand side. So left hand side also multiplying the conjugate for Z1 and Z2. Our answer is 13 minus I. Then for the right hand side, it will be the conjugate for the result. So we just have to change this to become conjugate. It's just a basic. So lastly, we show that we managed to prove this equation. So we managed to prove the left hand side answer equals to right hand side answer. So with this show question, I want to remind that when you're doing show, never do left hand side and right hand side together as this, like conjugate Z1, conjugate Z2, then you directly equal to conjugate Z1 and Z2. So from here, if you perform the working like this, you are showing nothing, yeah? At the last, you were showing doing at the last until 13 minus I equals to 13 minus I. So this question is asking you to show that this operation, where these different operation, they will be equal to each other. So it's not ask you to rewrite again. Therefore, in showing, so never do left hand side and right hand side together in both sides. So for this equation, it doesn't mean anything. If you see 13 equals to 13, it doesn't mean anything. You cannot show that this operation is equals to that operation. So you have to separate out.